do C. From past orders, has to do 1C, and I cannot see the graph, couldn't get the whole picture on there. So I'm going to try to explain where all of this comes from. But because this says this limit, that limit can be evaluated using L'Hopital. What that tells me is this top value, when you plug the 3 in, when you do the limit, as x approaches 3 of this thing, when you plug 3 in the top, it has to go to 0, and when you plug 3 in the bottom function also goes to 0. So that means we can use L'Hopital's rule to find that, and we need to know that in order to get f of 3. So from that, I know that the denominator has to equal 0. So because the denominator equals 0, I know that the limit as x approaches 3 of the denominator minus x has to equal 0. That is what that tells me. So what that tells me is that this part here, come on, machine. There we go. This part here has to have a value of 1, because when we plug in 3, which is what we're supposed to do with the limit, so when I plug in 3, let's go back to red. When I plug in 3, that also has to equal 0. So then that tells me that from that, I get that this part up here has to be 0, because this whole thing, e to that whole power, has to equal 1, because 3 times 1 minus 3 is 0. So what that tells me is that 2 of f of 3 plus 5 has to equal 1. Nope, sorry, 0, because I gotta have the 1 for the whole value. So if I subtract the 5 over and divide by the 2, that gives me the first part, f of 3 has to be negative 5/2. So that is the first part, finding f of 3. Now I'm supposed to actually find the limit of this thing on the bottom. So I'm going to do that now. So again, I'm starting with the limit as x approaches 3 of that whole thing, and I already know it says it has to be evaluated using that. So that means I can't find that value, because again, the top goes to 0 and the bottom goes to 0, which tells me I can use L'Hopital. That's what the evaluated by L'Hopital is implying, that both the top, the numerator when you plug 3 in, and the denominator when you plug 3 in, they both go to 0. So L'Hopital says that I can do the derivative of the top and the derivative of the bottom. So when we do the derivative, the limit as that original thing goes to 3, it will also equal the same thing as the limit of x goes to 3 for the derivative of the top. So you leave the coefficient 3, and then when you do an integral, the derivative of an integral, they cancel each other out, but hopefully you remember, since that top interval is 3x, that is the second fundamental theorem of calculus. So when I do the second fundamental theorem of calculus, it says I've got to type in or plug in that value at the top that has an x with it, in for the t, and then I also have to do a chain rule with that, and I have to do the derivative of 3x, which is times 3, and then the derivative of negative 4x is just negative 4. And then you do the derivative of the bottom part all by itself. So hopefully you remember that when you have an e to a power, that it is exactly the same thing, e to the power. So your coefficient 3 stays the same, so you get 2f of x plus 5. And then you have to take that times the derivative of the numerator. So the derivative of 2f is going to be 2f prime of x, and the derivative of 5 is 0. So that right there is the chain rule for that thing. And then I have this minus x down here. So the derivative of minus x is minus 1. So that is the entire derivative of that. And now I've got to plug 3 into all this stuff because I'm doing the limit as x approaches 3. So I'm going to get 3. F prime of 3 times 3 is 9. And I'll tell you what, I'm going to take this 3 and multiply it over there by that 3. Instead of having the 3 in front, it's going to be a 9. Then I got this minus 4 over here. Then on the bottom part, I've got 3 e to the 2 times f of 3 plus 5. And then that's times 2 f prime of 3 minus the 1. So now I got to plug in numerical values for all of that stuff. So f of 3, if you remember, we just solved it a little while ago and got negative 5 halves. And if you recall, that negative 5 halves, we use that for when the exponent. In other words, this whole thing up here becomes 0. Do you remember that? I hope you do. Or you could plug in negative 5 over 2 for that and solve it, and you get 0 out for that whole thing. And then f prime of 9, we have to get from the graph up at the top. And the graph at the top, this x equals 9 tells me that that's a tangent line, and you should be able to tell that that's hitting the x-axis. Okay, so that's going to be 0, because that is the f prime graph at the top, and the y value there at 9 is 0. And that's minus 4. And then down here at the bottom, this e to the 0 is just e, so this is still 3. And then f prime of 3, if you look at the graph up there above, f prime of 3 is 2. Oh, I'm sorry, we got this 2. And f prime of 3, it tells me on the graph the ordered pair is 3 and 3.5, so I got to stick 3.5 in for f prime of 3. Then I still got minus 1 there. And you could quit right there and be done. You do not have to go any further. Or you could go ahead and solve the rest of this thing. And when you solve the rest of this thing, you're going to end up getting negative 1/5 if you go that far. But again, you can stop right here after you get all the numerical values in. You do have to tell what f of 3 and f prime of 3 is. So you do have to get to that step.